Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com Roundtable, brought to you by Techstrong. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting panel ahead. First, I do need to cover just a couple of housekeeping notes. Today's conversation is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab, which can be found on the right side of the screen. Over on the right side of the screen, you'll see a couple of other options, the first of which being the chat tab. And that's where we want you to have more general discussions about our content today. Maybe let us know from where you're tuning in or what role you play in your organization. If you navigate to the handouts tab, you'll see that we have a preview of a survey that's being conducted by Firefly, as well as a link to actually participate in that survey. So do feel free to check out that link if you'd like to fill that out. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our topic. So our topic today is infrastructure as code. And I'm joined by Ido Niemann, CEO and co-founder of Firefly, Alex Kokinos, senior sales engineer at Strong DM, and moderating our conversation today is our very own Mike Vazard, Chief Content Officer at Techstrong Group. So Ido and Alex, thank you both so much for joining us today. Mike, how would you like to get us kicked off?
All right, well, thanks for the handoff. Ido, let's just start with you. And not everybody has the same level of experience with infrastructure as code tools. And we've been talking about developers forever and a day and full stack and shifting left. And yet, we know that there are platform engineers and SREs and all kinds of folks using these tools. So walk us through the spectrum of who's getting the most out of these tools today and why, and what are you seeing?
Fantastic. So first, thanks for having me, Techstrong and Mike and Alex. Thanks for joining this conversation. So I'd like to point out that as a market participant or as part of the DevOps or CloudOps community, I've been speaking to lots of practitioners all day long, but just recently here at Firefly, we released a survey, a community survey about the adoption and patterns of usage in infrastructure as code. So I can give you a sneak peek into some of the insights we got. So it's not my opinions I will share, or not only my opinion, and I try to give you mostly the snippets of data that we seen from this survey. So starting with your question, Mike, we surveyed some few hundreds respondents across a lot of different roles in the industry. We still see majority of infrastructure as code practitioners belonging to the DevOps practice. So most of them are DevOps engineers. So most of the respondents tell that for their company, the more than 80% of infrastructure as code is written by DevOps. Then it's interesting to see, obviously we see next in line SRE or CloudOps, but then more than 30% of infrastructure as code that is being written is now attributed into developers, mostly back-end developers. And this is very much interesting because we do see the shift left movement happening in infrastructure as code. We all started with the more basic tools like Chef, Puppet, Ansible, Terraform, obviously, but now with the rise of Terraform SDK and Pulumi and CloudFormation SDK, it allows those backend teams to write infrastructure as code using, let's call it, a backend syntax. So it's probably a shift in the market that are beginning to see. What I'll finish my answer is that what we now believe and seeing across our customer base is that the platform and DevOps teams, the central teams, build the platforms and they build the core part of it. But the Scrum teams across the organizations, they sometimes have some ability to change the infrastructure to their specific service needs. And this is where you see the developers writing the infrastructure code themselves.
All right. So just to clarify that a little bit, the core is written by somebody who's an expert in the platform, but we're finding some interesting ways to enable developers to self-service themselves and kind of deliver some tweaks to that platform to optimize for a particular workload. So, is this becoming more of a team sport in your mind?
Only a team sport. It's a team sport, but it's not a bunch of individuals. It's a bunch of squads, right? So what it does, it it increases the complexity. So as I mentioned before, you have this central team using, let's call it Terraform, CloudFormation, and Helm charts for Kubernetes. Then you have some Scrum teams adding in Terraform SDK and Pulumi. So you have all of those different moving parts in different squads contributing to what essentially is a unified microservices working together. So it gives us more agility and it allows us to move faster and more efficiency. But for the central management of DevOps or SRE or engineering, it increases the complexity and the headaches.
All right, great. Alex, does that resonate with your experience? I know we didn't introduce you in this way, but you are a recovering SRE. You have some experience in that space. Does this all sound familiar, or is each individual DevOps shop different?
For sure, I think every organization is going to have their own nuances, and a smaller shop will be a lot different than a bigger shop. But I think what really resonated with me with that take on it is, when I worked on some Terraform modularization and providing a pipeline for the whole company to use, moving from, we started really with a mono repo type of Terraform situation, very classic. The infrastructure team does everything. And then we moved over to a pipeline that everybody could take advantage of. And when we did that with Terraform, the very interested development teams who maybe were already interested on this hobby level of infrastructure, they would pick up on Terraform and play with it. But then other development teams weren't very interested in it at all. And then when you start talking about Terraform SDK and Pulumi, those type of more programmatic technologies, I think, are a little more appealing and take it to the next level, really. And just like Ido said, it would increase your complexity because you're really allowing more teams to have freedom, which will give you more productivity, but then you're adding another layer of things that you need to manage on top of that, if that makes sense.
It does. Let's follow up on that for a second there, because as it's a team sport, when originally we started talking about all this stuff, it was the assumption that you were going to be working out of some CLI and invoking APIs. And my question to you is, are you seeing more people use GUI tools to manage infrastructure as code, and they're kind of flipping in and out of GUI tools and CLIs as circumstances warrant, and it's not an all either or proposition one way or the other these days, depending on who's using it for what purpose when?
So I think that managing infrastructure as code using GUI or UI is oxymoron. We call it infrastructure as code. It's code, not images. Essentially, what we did is we switched the images on our cloud service provider and ClickOps, what we call, and traded it for code because code is more consistent. So using those ClickOps is all ClickOps methods. It's almost like not believing in the infrastructure as code. And maybe it's a good point in time for me to share another insight from our survey. Two interesting points in my opinion. We asked, what got you adopting infrastructure as code? So first reason, which got surprised me, was consistency. Platform managers, CTOs, VP of infra want every practitioner who changes the cloud to do it in the same manner. Second place was reliability. Obviously, for me, personal top one. Then you have the velocity, the dev velocity, how fast can you change the cloud. And only later comes security and cost control. But then when we ask them, how is the adoption of infrastructure as code really contributed to your organization? We got not a fully aligned answers. So you got first place engineering efficiency. So this is what Alex mentioned and what we talked earlier. It allows more teams, more people in the organization to deploy faster to the cloud. You don't have to wait for the central DevOps team to spin up your environment to connect your network to your database. You just do engineering efficiency is one. Then you found less downtime, which makes a lot of sense. And in third after this is faster troubleshooting. So if you want to get higher efficiency, if you want to get more reliability, more consistency, bundling them all together, if you build it on top of GUI clicks, it just doesn't make sense, because just like I'm writing code and I wanted to move through my CI/CD pipeline and go through all these tasks and procedures, same goes for my infra, because in the modern day, changes to the service or to the application are very much reliant on the infrastructure. So if it doesn't go through the infrastructure, it doesn't handle and manage as code, it's literally inefficient and at risk. So as we see it, ClickOps is something that should go away. And we every day, lots of teams, you said Alex was a recovered SRE, is recovered and not continuing this very intense line of career, because SREs are constantly putting out fires. Some of the core reasons that infrastructure fires happen on the cloud is what we call drift, right? You have one desired state you defined using your Terraform or CloudFormation or Helm, but now someone in some team or some hour of the day goes into the cloud and change it using the GUI or directly through the AWS CLI, let's say. So this is a bad practice, because other teams, or you mentioned the other players in this team, are not aware of this change. So this is why drift happens. This is why mistakes happen. This is why service are getting hit and shut down. So as I see it, ClickOps and GUI are very, very bad practice.
All right. Well, we already have a question from the audience about that, but one of them seems to think that, one of the issues with Azure DevOps pipelines is it comes with a GUI. And so they're like, are the vendors kind of pushing people in the wrong direction for best practices here? Or, is it up to me to find some other way around that so I can invoke those APIs myself?
Yes. Yes. So Alex, go ahead. Go ahead. I talked too much already.
I was going to say, I think, for Azure DevOps specifically, I actually got the chance to do some work on that around when they were changing the name. I think it was 2018. So it's been a long time for me, but I think they are trying to put some more code in there in the, I believe they have YAML-based tasks and build pipelines. But again, don't quote me on that. But where I like to see sort of that ClickOps or the UI, I like to see it as a view of what you're doing, rather than I'm in here clicking. Something like Terraform Cloud, where you can configure it to click through and do things in the UI, but I think the way they really want to do it is have you tie it into your source control and more lock it down to that.
All right. We have one comment who just notes that GUIs are great when you work for the government or bureaucracy, but other than that, I guess not. So the question I would ask from here, though, is, will everything be managed, therefore, by SREs or infrastructure, or is there room still for your traditional IT administrator and with his IT service management framework and all that stuff that's been around forever, or is that going to fade away because ClickOps is a bad practice?
Personal approach is that it's going away. all of the things that we are very much were accustomed to in, let's call it, the on-prem data center. All this IT asset management is great. It's a necessity. You can't run your own on-prem infra if it's not properly managed. But when we shift to the cloud, we need to have a much more agile way to do the things, to do the same processes. We need to have a unified visibility to everything in the cloud and ensure that everything is properly codified. Because, let me give you a very esoteric example. One of the companies I'm very close to, they have almost 16,000 servers only on their production environment on one AWS region. Okay, so it's massive. If you try to change them all manually, it will take you forever. This company changes those servers something between 4 and 8 times a day, including the weekends. Okay, so it's literally not like managing our own data center. So what I'm advocating for, and thankfully I'm not the only one, is that we need to take those great tools and approaches that we have for the last 30, 40 years for IT asset management and bring them into the cloud. And infrastructure as code is the great enabler of it, because with infrastructure as code, my entire cloud speaks the same language, the language of infrastructure as code, which has many different dialects. So I can just leverage it to control everything. So I would tell you, you need to control everything in your cloud with infrastructure as code, from cloud providers to Kubernetes and up to your SaaS applications. My personal experience with Cloudflare, Datadog, Okta, you name it, even Strong DM. It's best for me to manage it with infrastructure as code, because this is how I can ensure it's fully visible, fully in line with my policies, and any change I do to one part of my infra is well acknowledged for the rest of the microservices that are affected from it.
Let me just follow up too, since we are living in some challenging economic times, but do you think that the math on this is fundamentally in favor of the SRE CLI approach? Because if I get an SRE and they can manage, I don't know, tens and hundreds of servers, and they cost, I don't know, $150,000 a year, how many admins would I have to get to accomplish the same thing at $75,000 a year? So the math might be lending itself more towards this SRE approach anyway.
Exactly. I would tell you, another nugget of information from our survey. We found that more than 53% of respondents invest more than a full-time employee just in creating and maintaining infrastructure as code. And this employee is probably, in the best case, a DevOps engineer. In the more costly use case, a very experienced SRE or platform engineer. Okay, so some of them are spending or investing more than 6 full-time employees. So it's a lot of investment. What we advocate for is, yes, you gotta manage and control everything with infrastructure as code, but we got to find the way to make it more efficient. Not, cloud scale, hopefully to infinite and back to zero, but we also need to scale our teams with current practices. We need to find the way on how to manage infrastructure as code without scaling the team, or at least without significantly scaling our team.
All right. One of our attendees has a question related to how you describe the way servers were managed. So they want to know, when you change servers, does all that happen like in flight, or do I have to take things offline, back up the data, and still make all the changes? Or, how deep can I get programmatically to kind of manage that process?
I could take this answer. So definitely depends on what resources we're talking about, and I think it also depends on the architecture of your application. So in Terraform, for example, when you plan and apply a change. In some cases, it can just modify existing resources. The SRE mentality tends to be, we like to do, if you've heard the phrase cattle, not pets, we like to replace entirely, throw things, well, first spin up something new, make sure it works, and then once we put that in production, we make sure, okay, we don't need the old thing anymore. Of course, that doesn't work with things like persistent data, like in a database, or maybe a queue, but so the answer varies there. But I think when you get the most sophisticated with infrastructure as code in general, you're going to be thinking about, how can I put things in modules or a modularized organization where I want to build another one of these, but I want it in the EU for my GDPR compliant part of my business. I already have all this infrastructure for the US. Gosh, that looks like a big project, but if you built it in this modular way with code, then that's not so much of an issue. So I think that's why it's so important to, especially when you're choosing management products, you know, that you're going to use with, beside your infrastructure, you have to ask yourself, is it going to work with my infrastructure as code tooling? Do they have a supported Terraform provider? Does their onboarding process make you build your own VM images, or do they make you, when I see a vendor that says like, all right, like go on the box and run this script, and that's how you install our special client, that worries me a little bit, because I want a vendor to say, you can, here's our Amazon machine image, here's our Docker container, here's an example of a Helm chart for us, or all kinds of different ways. Here's my Terraform provider. You can make it. Here's your example code to get started. So those are the things I like to see. But yeah, for a very long way to answer that question. But basically, it depends. But in a lot of cases, yeah, you can maybe change something that's there. But usually, it's safer to, if you can, create something new and just replace what you had before.
All right. It depends is always an answer to just about every IT question I've ever heard or asked. But, we do have a follow-up question to something you were kind of alluding to, but maybe they just want a little more detail. But so who should actually be writing the Terraform modules? Because it doesn't sound like it should be the developers, but rather a DevOps engineer who is writing them on behalf of developers. Is that what we're looking for?
It's tough. I think it's a really, I mentioned earlier in our discussion, when we tried to provide more visibility into the infrastructure for our developers, some are more interested in than others, and some of them need more customized solutions than others. When you think about platform engineering, it's this balancing act between giving something that is not going to cause everybody to be running something totally different, but then be flexible enough to not block people, basically. So as far as receiving that buy-in, I think this latest question is really about manager buy-in and removing roadblocks from older IT mindsets. I've seen a situation that was more of a show and tell. I had an experience with a security team who was very, they would come to us and say, can you log on to your servers and install the patches that we want you to do? And we would kind of be a little bit confused, because we're like, these are auto-scaling instance. If I go onto the instance and I install a patch, tomorrow the instance is going to be gone and replaced by a different one. So that's where I felt like show and tell was part of the way that we got some buy-in, was sort of to say, hey, if you want to install your security, so your security agents or install patches, let's set you up with this special repository for the security team and train you on it. As far as manager buy-in, I feel like I don't have a good answer for that because it's such a complicated and technical area that it's hard to explain. It's even hard for me to think about as somebody who did it for a living. So good luck.
Yeah. Ito, do you want to jump in here on any advice for management buy-in? How do you get the guys at the top of the food chain who never programmed anything to understand what we're doing?
So I can only tell you from my very poor and lean experience in helping our customers uh, um, convincing their managements. Okay, so and let's take it to the hardest level. You are a Fortune 100. You have massive infrastructure. You have managers who's really high up that they don't know what infrastructure as code is, let alone Terraform and how you will go about it. Now you need to tell them, listen, I have to put a lot of resources into this project, and what gets them excited almost about it. You tell them, okay, you were already, so prerequisite is that you were convinced that you should move to the cloud. Now if you are convinced that you should move to the cloud, you want to have one, reliability, you don't want it to go down, b, consistency as mentioned before, and lastly, you want efficiency. So not just like you manage your own code. Imagine that you just write a line of code, you deploy it, it becomes a binary, it goes to the service, and then you forget about it. This is what actually happens if you manage your cloud without using infrastructure as code, right? It's ClickOps. You just wrote something, it changes something in the application. In this case, it spun up an API in the cloud, and you forget about it. You don't manage it as coming back to the software to the application in Git. But we all want to manage our software in Git because it allows for collaboration, it allows us for versioning, it allows us for better testing, better security, better efficiency. All right. So same goes for the infrastructure. When cloud infrastructure became a utility, it meant that you need to step up your game in how you manage it. And the first principle is control it all using infrastructure as code and ensure everything looks like the way you want it. So if you, I would say, let's work the other way around. If you don't have infrastructure as code, how do you control? How do you see? How do you change a platform across different regions, different clouds, different vendors, different teams, different geographies, right? It's almost impossible. And this is what gets management the buy-in because they understand, A, I'm saving a lot of money due to engineering efficiency. B, I'm preventing the next service failure or disruption. And C, I'm making my platform modern to allow me to innovate faster when my competition is not slowing down.
All right. So I think what I also got out of that is if you use the term ClickOps with just the right sense of derisive tone on it, that the management people will understand that they're kind of behind the times. And so, you just kind of have to get the right spin on how you use that phrase. Alex, one of the criticisms that you do hear about infrastructure as code pertains to security. And what a lot of folks will say is, a lot of this code is somewhat insecure, written by people who are not security experts. And a lot of these misconfigurations get created and they create these situations where you might have a port that's left open and data gets exfiltrated and everybody likes to point fingers at the guys with the infrastructure as code tools. But what is the real state of security with these tools, and where do these mistakes come from and how can they be avoided?
I think it is definitely one of the more fast-moving, in-progress parts about different infrastructure as code tools. Something for everybody at home to Google to find out. I mean, really, what Mike is talking about is if I'm an SRE and I have the keys to the kingdom, and I write my code and it says, let anybody in, 0.0.0.0, let anybody in, and that's bad, but I have the keys to the kingdom. So there's a few different approaches to that, and the thing to take home in Google probably is a new area, policy as code. So there are a lot of platforms or technologies where you can write code that actually defines what you're allowed to do within infrastructure as code. And now we're going like a bunch of layers deep into doing things as code, but it's real, it's out there, and it's good stuff. But this is also an area where strong DM is involved, where we are in the arena of infrastructure access. So if you think about, especially working with going from ClickOps to writing Terraform code, and you're thinking about how your engineers access infrastructure like databases and servers and things like that. If you have a platform that's surrounding, you know, simplifying the job of managing who's allowed to access what, do we know who they are we auditing them, are we logging them, and can we say with confidence what they're really allowed to do? And that's something where I think a lot of people are struggling with, oh, I've got like a million IAM roles, users for all my employees, and person A has different permissions than person B. That's something where, strong DM can help with that, or really just a lot of it's kind of being organized. I mean, it's a lot to think about, but I think once you think about those questions in your mind, it becomes a little easier to break apart and and um, and attack and get it figured out. Because the old way, like I said, has really been this sort of golden team, whether it was SRE or sysadmins or whatever you want to call them in the past. There was always this team that had trust of they're the admins and they can change anything wherever you want. But no, I mean, in modern business, you really want to be doing a least privilege model where, for example, an SRE, do they really need to be able to change production unless they're on call? Really, I think the only thing that should be changing production is your CI pipeline or your CD pipeline. So that kind of stuff is, I guess you could say, newer issues to think about that weren't as obvious before, I think.
All right. Is there a way to think about putting guardrails in place that, without getting in the way, that prevent people from doing things that are possibly not as smart as they could? Maybe there's an alert that pops up that says, "Danger, Will Robinson, this is going to end badly," or, how smart can the whole process get?
I think it's very interesting to see the tension between what Alex just mentioned and also participant 511 just mentions. There's a tension between those two perceptions. One is to tell, I want control for the centralized team, just like we used to have in the old way IT. If you want something from IT, you go down the stairs, you get to the IT manager, you ask for a new server, a new network, a new IP endpoint. The second approach is more agile. It tells, we need to change so quickly. Microservices allow it so much. We don't want to be bounded by infrastructure changes. So every developer, every assistant can make their own changes. So I think you got to have some balance. But in order to achieve this balance, you should give some leeway to every developer to do some changes. But you need to have the ability to monitor those. B, get notified on what Alex mentions, changes that can be harmful or risky for your infrastructure. And C, have a change log, because you want to understand what happened to your info. Because in the end of the day, if something bad is going to happen to your infrastructure, it's not the developer that is responsible, it's the SRE or the platform engineering. So and again, something very interesting that we saw from the survey about the state of the infrastructure as code is, we asked, how do you detect drift? And we see that most of the folks out there, just detecting drift manually after the fact. So 42% of them just find out after something went south. They understand it's bad. But then, 27% of respondents have some own internal homegrown solution to track those changes for, a developer made a change to your desired state of the cloud. So I think, wrapping up this question, you gotta, these days, you gotta have some fluidity, some efficiency and agility handed over to the teams, but you got to have some controls for you to track those and quickly remediate those. Because I can just share, a very interesting company had a drift in the DNS, and now for some of the subdomains, traffic goes to nowhere because someone changes the DNS record. So every second this drift is up in the air is costing them, tens of thousands of dollars due to, let's call it just a poor SRE mistake. But in the end, it's business. We got to keep the infrastructure up and running. So allow freedom, but track it and remediate drift.
All right. We have two questions that are kind of related to each other. The first one is the simpler who's creating the controls, but we also have this thing known as open policy agent and compliance as code. And so will more of these issues be addressed in the code itself, Alex? Is that where we're moving towards? What do you think we're going to evolve towards from here?
That's an interesting question. I think it's going to be a difficult one for me to answer, but I think it will depend a lot on another it depends answer. It's going to depend on your organization and who in the organization has some of the strengths that you need to, of course, on the implementation side, a lot of this is getting pretty technical and involves connecting things, many different things together in a lot of cases. So in the example of, maybe sending an alert when somebody in the infrastructure team is doing something wrong, that might be more than one tool connecting to each other. So it's very hard to describe what is that solution going to look like. So it's perhaps my cop-out answer is, I think at a lot of different levels of the organization, people need to just be aware and educated about the existence of some of these issues. In my journey of just learning some things, in general, I find that half of the battle is just knowing what to look for, knowing what to Google, knowing that something exists will get you halfway there, and then maybe that will help. But yeah, I feel like my answer isn't very sufficient because it's hard.
Ido, do you want to jump in here? Do you have any thoughts about compliance as code? And
Yeah, first of all, I'm a very big believer in OPA, in the Open Policy Agent. Even internally within our company, we use it daily. This is our guardrails. We use it both in the CI/CD pipeline, but also for us, more importantly, track things after they're deployed to the cloud. Constantly run benchmarks from our guardrails or governance tool set against the cloud. And we also offer this to our customers, a very easy way to adopt Open Policy Agent to run those checks across your cloud in security, reliability, optimization use cases. So I think, yes, this is the very good way to put the guardrails in a more compliance security manner. But I think for the people who are adopting infrastructure as code, we got to start with the reliability and building guardrails, because we mentioned some leaks of secrets or keys, obviously super important. But how about someone just dropping your VPC? Okay, how about someone just deploying a Kubernetes container without a liveness probe? So now it can be up and running, but if something goes down, how would you know? We wait for the service to crash. You don't want to know when the problem starts to sprawl. So we also very big advocates, and we offer this to our customers on how to leverage infrastructure as code in conjunction with Open Policy Agent to find this, and just taking here from the question feed one about the GitOps. Yes, I think GitOps is a great solution to have these guardrails, but you got to understand that GitOps is hard. We have very good solutions for GitOps around Kubernetes, but they are not full. Some significant parts of your infrastructure won't be covered using these approaches. Amazing tools like Argo CD, which is great, but also Flux and others. And B, it almost requires a very high talent density type of team. So if you have like the Airbnb, the Netflix teams, all the best of the industry, fantastic, go ahead. But let's say you're an enterprise with a mixture of different level of experience and talent and tools and availability, it will be harder to adopt across the organization. So uh, uh, um, I'm seeing lately many companies adopt a hybrid approach. So they have some sort of GitOps, but then they have a controller on top of it to ensure that the entire cloud is controlled and managed. Full disclosure, we help to some of our customers in this specific use case on how to adopt infrastructure as code in conjunction with GitOps. Uh, um, but this is how I see governance and control.
Well, let's just follow up on that a little bit, because one of the challenges you do see out there is, like, for every platform, it seems like there's a different approach for infrastructure as code, whether it's Kubernetes and this wall of YAML files or whatever else you put in front of it, or AWS has got its approach and Azure has an approach. And most teams that I know are working with multiple platforms now. So how do we kind of streamline this a little bit, make it more accessible to folks so that we can do infrastructure as code cross-platform without having to learn 15 different tools?
Yeah, I mean, for me, that's one of the reasons I am a big fan of Terraform in general, because it has every cloud provider under the sun. That's a big plus. And when I think about this question, I also think about a lot of people talk about multi-cloud or mixed hybrid environments, but if you're at a younger company and you're sort of like, that's all hype. I don't need that. We have everything on AWS and we're fine. But what happens when your company buys another company or merges with another company or is sold to another company? Then all of a sudden you have all of this stuff that you built that has to be managed together as one organization. So I think this topic also, I guess, at a tangent, it makes me think of Conway's law, which is that your code is going to look a lot like your organization. But if I can like weasel my way back to the topic at hand, I think it really is a matter of wherever you can, just choosing tools and products that are really flexible. There shouldn't be a really great reason, unless they're really specific to a specific cloud service. It should be a tool that's going to work nicely with you. If I need to change from AWS to Google Cloud, if I need to start doing on-premise, or I already have on-premise and I need to mix between those things. The the shameless plug is that StrongDM does do that, where we have an infrastructure access platform that will hit on premise. You're not dealing with 15 VPNs. You got a list of all your infrastructure and you can access it. But another thought I have on that sort of multiple environment situation is well, I lost that thought, so that's where I'll leave it.
All right. Well, Ido, let's follow up on that same conversation with you, but add a little spin to it. Should the cloud service providers be doing more to make it simpler, and what's their role in this whole conversation?
I would say that segueing from Alex is the exact framing of the problem. It's so complex that even someone as experienced, as talented as Alex is getting his thoughts going around and mixed, right? Cloud is super, super complex. And yes, you're correct. My cloud service providers are doing a lot. They try to help you, but by doing so sometimes they even make the problem more challenging, because how many different services do we have now by AWS? Like 15,000 and counting. By GCP, by Azure, by OCI, Oracle, and then add Kubernetes into the mix, and some serverless and OpenShift. Now you mix those all together, but yeah, maybe I'm running a MongoDB on the MongoDB Atlas SaaS offering outside, right? And I have some CloudFormation, some Terraform, some help for Kubernetes, obviously, some ARM on Azure. It's too complex. So to one of those questions here on the question feed on the chat, someone asked, who creates the asset management database? And I think this is exactly the point. If you want to control your cloud, you need a cloud asset management database. Just like when we all had our own databases, we had those asset management, and CMDB is a huge, huge, huge category, selling tens, if not more, tens of billions of dollars a year, if not more. So why don't have it to the cloud? This is the era now when we shift from cloud 1.0, when we all rushed to the cloud, adopted it, got some observability into it, but have a mess, have very high dependency on very talented, agile talents maintaining this cloud, into cloud 2.0, which is a more efficient cloud, managed cloud that works for us instead of our DevOps and SRE and platform engineering teams enslaved for it. And the clear requirement to get there is start with a cloud asset management solution. There are a bunch of those. Probably the best one is Firefly, and sorry for the shameless plug. Uh, um, but what essentially those cloud asset management solutions do is give you a unified inventory into your entire cloud footprint. It doesn't matter if you run 50 AWS accounts, 60 GCP projects, 100 Azure projects, and 140 Kubernetes clusters. You see them all in one place. You see all of your SaaS applications that are important, like StrongDM, like Okta, in one place. Then you're able to tell which of those resources, something can be millions and billions of resources, are covered and managed with infrastructure as code, to our topic, which are not. And then there's the big question on if those tools can automatically generate the infrastructure as code for you or not, and one tool for Drift or not.
All right, Alex, this next question is for you from the audience, but how do you deal with documentation? It's this trivial little thing that goes on anytime you write a program or something. Somebody wants to know what you did with it, and is there a process for that?
I love documentation. I know. I think the agile methodology has maybe people misread it as being like, I don't need to document my code, but I think step one obviously is to know your audience. Who are you writing your module for, or who are you delivering whatever you're delivering to? So I like to write documentation in a way that really assumes almost no knowledge, and it does mean that I have to rewrite it more often as the project evolves, but I'm always thinking about, what if I'm not here tomorrow? I certainly don't want anybody trying to contact me when I'm on vacation, so that's a selfish reason to write good documentation. But I think write it, as soon as you have something that works. I like to just spend a little time and write a README. It doesn't have to be amazing. It can say, hey, this part doesn't work so well right now, or this is a huge caveat. I haven't figured this out yet. This is incomplete, work in progress, whatever it is. But I love to see it, even if the documentation is just saying, I haven't really documented this yet, but here's the general idea of what it's trying to do, and maybe a couple of details here and there. It doesn't have to be necessarily step by step, but something's better than nothing. That's how I feel about it. And like I said, again, I must emphasize, don't keep things in your documentation that aren't relevant anymore. It's just one of those things. People don't like spending time on it. Just spend the time. You've got some time in your day. I'm sure you'll find some time to do it.
All right. I think you may be the conscientious exception to that rule, but we'll see how that goes. Ido,
Probably.
can all this get smarter? I mean, can we maybe throw AI algorithms at documentation, the management of this process in general? Where are we going to be a year from now in your mind?
So for sure, some teams are trying. I'm familiar with a company that does exactly this. It tries to understand your code and automatically using AI generates the documentation. We personally at Firefly, we offer our customers a way to see your cloud, automatically generate infrastructure as code out of it, but then also learn what your infrastructure as code is comprised of and automatically generate modules out of it. So definitely we'll see machine learning, advanced algorithms, and one would even say AI coming into this field in the near future.
All right. Alex and Ido, I'm going to ask you both the same question. I'm going to go to Alex first, but what do you know now that you kind of wished you knew 2 years ago, 3 years ago? What would you share with people to kind of reduce their level of pain, or what sometimes we refer to as the idiot tax, because you didn't know going in? So what's the thing now that you just going, wow, my life would have been different if I knew that 2 years ago?
Oh wow. This is easily the hardest question. What do I wish I knew? I think this is really specific, but I think I would have started using Terraform Cloud for my personal projects earlier, just because it's free. So maybe that sort of thing might apply to some other things. I mean, I know you can get burned on that. Like if you're like, oh, I'm going to use Heroku for my free stuff, and then now they don't have a free tier anymore. I mean, you can get burned that way, but that was a wish of mine. But yeah, I mean, that's just such a hard question. I wish I had more of an insight, because I'm sure there's a laundry list somewhere. But I think as a generality, as I've moved into the sales organization instead of the technical organization, and I think it's always been something I've been pretty good at, but the idea of knowing your audience, I mentioned that already. It's a really good skill to have, and finding out what people really want, because if you're thinking about expanding an infrastructure as code practice, you've got developers, you've got maybe security teams. Everybody has different objectives, and management too. Management is all revenue, costs, and risk. So in sales, we use discovery questions. We ask open-ended questions like, describe for me how this is working for you now, or what pain what pain does this cause for you? What would it look like if this was better? And those are kind of life skills that you can use with different teams. And so I think if there's a more vague version of what do I wish I knew, I wish I had known more about what each team that I worked with, what their motivation was, what they care about. So anytime you can find ways to find that out, that's always good to know.
All right. Variation of the same question, but what's that one thing that you see customers doing that makes you shake your head and go, I can't believe we're still doing that? And what's your best advice for fixing it?
So I think that one of the things I see them doing is starting to adopt infrastructure as code, and not understanding, not watching Spider-Man just after doing so. Infrastructure as code is amazing. It's super powerful, but with great power comes great responsibility, right? So just earlier today, I saw one of our customers doing a mistake, and now it will sound a lot, but I'm not exaggerating. That cost them $600,000 for nothing a year. And why is that? Because we use infrastructure as code, we think it's cool, we start to adopt it, we do some changes to the cloud, but because it changes only part of our infrastructure and the rest is deployed by ClickUp, it's not synchronized. So let's say you have some compute, it goes up, some storage goes with it. Compute goes down, storage stays up. Compute goes up again, storage goes up again. Okay, so in 2 weeks' time, they created excessive cost of $600,000. I'm not talking even about reliability and security issues. So I would say understand infrastructure as code is so powerful that it can make or break your cloud. So use it, of course, but use it wisely. Take the right tools to ensure that you're doing the right job while adopting it. Uh, um, and please don't stop in the middle when it gets hard, when it gets challenging. Just go all the way, and it's fine, and it's worth the investment out of the gate.
All right. Well, let me just follow up with you specifically on that topic. Ido, do you think that there's a lot of work still to be done in terms of standards in this space? Because it does seem like we're reinventing the same wheel for different platforms. So maybe we should all just take a giant step back and say, it's not a lot of differentiated value in exactly how I programmatically manage infrastructure. So maybe we could all just come to some agreement about the way to do that the most efficiently and, give everybody a break. Is there an opportunity for the standards bodies to weigh in somehow?
As a general philosophy for life, I'm very liberal. I want everyone to do what's best for them. All right. So say, and especially when it comes to code and infra. So for some, the best common API is Kubernetes API. For most of us, it's infrastructure as code. For others, it might be ClickOps or platform as a service, right? So I believe we're already there, and standards are not missing in any place to make our lives easier.
Alex, you generally agree with that? It's basically de facto standards, and whatever people are using is the standard of the day.
Yeah.
I think, and again, as a generality, I would agree with that in terms of, maybe from a different angle. I agree with it in the sense that we're seeing a space where it doesn't matter quite as much which cloud provider you go with. You can do a lot of the same things as long as you make reasonable choices. And many of these cloud services are very similar, maybe no difference at all. I think of S3 having so many basically clones, like compatible services that are nearly identical. I think some of them even claim that it's like 100% identical. It's like totally the same thing. But then anything new that's being innovated actively is going to be a little different between each service. So I think we're in a pretty good place in terms of, if this was 1995 and you told me that Microsoft would spin up a Linux VM for you on their cloud, like, would you believe me? Like, no way. So it's not too bad. There's not, can we get Amazon and Google and Microsoft to agree on everything? Probably not.
All right. Well, we hope will spring eternal, as they say. Gentlemen, thanks for spending the time. An hour has flown by before we even realized it, and we're going to hand it back to Cody, who's going to take us out.
Awesome, Mike. Thank you so much for the pitch and for leading this conversation. And to Ido and Alex, thank you both for joining us today. I would also like to point out that there is a link to the survey, both in the handouts and in the chat, as well as pinned to the top of the chat window. So if you'd like to participate in Firefly's ongoing survey, I do remind you those links are there for you. And I'd also like to remind everyone this session was recorded. Following this program, you'll receive an email with the link to access the recording on demand, or you can find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. We do still have those 4 $25 Amazon gift cards to give away, and our winners are Terry M., Sylvia O., Bradley M., and Don A. So So to our 4 winners, congratulations. Keep an eye on your email inbox to claim those gift cards, but if you don't happen to see that email, please do check your spam folder. All right, Alex, Ito, and Mike, thank you all so much for being here. And to our audience, thank you for spending the last hour with us as well. We really value your time and we value your feedback as well. So you should be receiving a survey up on your screen as soon as we close out, and we'd really appreciate your feedback there. Let us know how we can improve on upcoming programs, or maybe what you'd like to see discussed, or all your input. Just send us your input. Have a great rest of your day, everyone, and we hope to see you all at an upcoming Techstrong Learning program.
Thank you all.